All right, so I'm going to take you through a couple of problems on wave calculations from your textbook. So this is waves, page 388, and the problems 21, 23, 25, 36, 37, 42. And today I will take you through 21 and 25. So you'll have 4 more to do on your own. All right, starting in with 21. A nurse counts 76 heartbeats in 1 minute. What are the period and frequency of the heart's oscillations? So we know from the problem 76 beats per minute. Now frequency is like something happening per second. So we'll go ahead and say 76. Do this. So frequency is from your little formula there, a certain number per time. And so frequency is going to be 76 beats, not per second, but per 60 seconds. So in the calculator, 76 divided by 60, 1.27. So 1.27 beats per second is our frequency. Okay. Now the period is like how long it takes to do one beat. So if there's 1 1/4 beats every second, how long does one beat take? So the formula for that is period is equal to 1 over frequency. And so put 1 divided by 1.27 beats per second. And when we do that, 1 divided by 1.27, that means that it takes 0.779 seconds for a heartbeat. So just like 80% of a second, or 0.8 seconds for every heartbeat. Okay, 23. Calculate the speed of waves in a puddle that are 0.15 meters apart. And actually, hold on. No, I think I want to do 25 with you, sorry. All right. 25. The lowest frequency we can hear is about 20 hertz, or 20 beats per second. Calculate the wavelength associated with this frequency for sound that travels at 340 meters per second. How long is this in feet? All right, so we know that our frequency is 20 hertz. And we know that the speed of sound, speed of that wave, is 340 meters per second. And so we're looking for the wavelength equals question mark. So our equation that we'll use is that speed is equal to wavelength times frequency. And I guess in your book, I'm sorry, in your book that's a lambda. It's just the Greek letter for wavelength, so wavelength. Speed is equal to wavelength times frequency, so we'll say 340 meters per second is equal to wavelength times 20 hertz. And then in order to solve for lambda, we'll divide both sides by 20. 340 divided by 20 is 17, right? 340 divided by 20, 17. Okay. Lambda is equal to 17 meters. All right. So 17 meters long. Decent length. Probably like double our classroom, I suppose. 17 meters. And we'll go and calculate this in feet. I don't know what it is. Meters to feet. 3.28. Okay, so 1 meter, 3.28 feet. So our meters cancel out. 17 times 3.28. 17 times 3.28. 55.8 or 56. So we'll go 56 feet. So there you go. That's the wavelength of the lowest frequency we can hear, is that every wave is happening like once every 56 feet. So there we go. You'll just have the rest of the problems up top to do on your own.